All right. So, okay. So I posted tutorial 8 this morning. I hope you're able to see the screen here. It says tutorial 8. Okay. This is also very simple and straightforward tutorial. In fact, some of the programs are already given to you in the lectures, and others, at least, we have described the algorithm in terms of how you have to proceed. Okay. So the first one is basically you would develop an MPI program that computes a matrix vector multiplication, okay, and produces the resulting vector using block decomposition along the rows. Okay, that means you would assign several rows to a process and the remaining other rows to another process and so on. Okay, you would decompose the rows and then assign them to different process, and then you would do the same thing with the right hand side vector as well. Okay, then essentially you would convince yourself that you obtain the same answer as that of the serial program. And what I want you to do is basically use collective communication functions as much as possible wherever they are needed, okay, rather than using send receive. Okay, then I mean, this is kind of indicative. You can use some process p equals number of process equals 2, 4, and 8, and then see if the program runs correctly and gives you the correct answer. Okay, so that is the first problem. Second problem is related to basically, again, testing the different collective communications such as MPI reduce, MPI all reduce, scatter, gather, and all gather. Okay, so these, I think most of them we have seen in the lecture. The codes are also available. Maybe I have probably not done all gather. I don't remember. Maybe I have done it as well. Essentially, you just have to run it. If you are a Fortran user, you probably have to write these programs. I didn't, because I didn't share them. I didn't write them in the lectures. Okay, and then you basically have to again note that by running them, you are getting the right answer in terms of the the function calls are doing what they are intended to do. Okay, so that is the second question. Then I added a couple of more programs or kind of items here, which kind of introduce you to some new functions that we didn't learn in the lectures. So such as MPI W time and MPI W tick and MPI barrier, but these are kind of obvious functions with our introduction in the OpenMP. So you should be able to kind of look these up and then kind of explore and learn how to use them and what how to call them, the function prototypes, and then what are their uses. How would you use them in a program? So essentially, once you know that, you can try to time your matrix vector multiplication program for different sizes of the matrix. Okay. Okay. So all right. Then finally, I also included some more functions, which some of them you would be using, some of them you may not be using so much. So the first one is basically, instead of MPI gather, we have another couple of functions known as MPI gather V and then MPI scatter V. Okay, so these basically allow for variable sizes, of the arrays on different processes. So you would basically look them up again and then see how they are different from their counterparts, which are MPI scatter and MPI gather, how they are different. And of course, because you have a variable thing, you basically have to kind of pass in the displacements as well on, how much are these variable arrays available on each process and things like that. So you would look them up. I'm not sure whether you would require these in your, let's say, research or in the programs you would do, but nonetheless, it's kind of a good idea to learn about them. Then finally, we have these MPI dimensions create and cart create, and then something known as cart rank and cart coordinates. But these may be very useful to you if you happen to work with, let's say, 2 dimensions or 3-dimensional Cartesian decompositions. Okay, so that means let's say you want to arrange your process in a 2-dimensional grid. Let's say you want to have P0, P1, P2, P3, or in any other order. or you may want to also have a three-dimensional decomposition in which you have P4, P5, P6, P7 behind these ones, and so on. So when you want to create processes not only along 1D, but you want to decompose them, your domain using process in all other dimensions, okay, in 2D or 3 dimensions. Okay, then these may be useful. Okay, the cart create, dimensions create, and then so here cart basically stands for Cartesian. Okay, and the dimensions will basically tell you whether you're working with a 2D or a 3D. And then in a Cartesian process, it will basically give you what is the rank and what are the coordinates. Now the coordinates is something which will tell you whether you're looking at 0, 0, 1, 0 or 0, 1, 1, 1. So you would basically able to obtain from these coordinates, you can easily map these processes, and that will be useful when you try to do the communications. Okay. For example, you would be able to set up who are your neighbors. So, for example, if you are in a particular process P, who is your left neighbor, right neighbor, top neighbor, and forward neighbor and backward neighbor. All these things you can easily fill by using when you set up your program using these functions initially. Then for every process you would be able to very easily fill up your neighbors. Then you really don't have to worry about sending the data and receiving the data, because your neighboring process numbers would be known automatically, and it will be inquired and filled up by the MPI using these function calls. As a result, you will be able to very easily send and receive programs, send and receive the communication. Okay, because as of now, what we have been doing is we are saying, okay, I just have a 1D grid in which I say this is process 0, 1, 2, and so on. So what we said was, okay, process 0 sends it to 1, 1's neighbor is 2, 2 neighbor is 3, and so on. But such a system is not, such thing is not obvious when you go to 2D and 3D, and also you may be able to generate all these neighbors automatically, irrespective of the number of processes you will work with. For example, today you will be working with, let's say, 10 processes. Tomorrow you may write, you may use 10, 24 processes, and so on. Okay. All right. So that's kind of a very quick introduction to these things. But what I want you to do is I want you to kind of spend time, understand these things, and also ponder where they may be useful. I think these, I'm hoping that these will be useful in your MS research or your projects and things like that. Okay, fine. All right, so that's all about this tutorial. Then before I kind of ask you some questions, or kind of open it up for questions, I want to make a few announcements. First thing is, so next week is a semester break. So no classes next week. Okay, because of the semester break. So we don't have 3 lectures. I will not be posting, and also we will not meet. So no Q&A session as well next Friday. Okay, so the next lecture will only be posted on Tuesday. That would be 5th of April, I suppose, right? Tuesday, 5th of April. Is that correct? Yeah, I think it's 27th to 2nd. So I'll post it on either 5th of April or sorry, 6th of April, or maybe I'll post it on 5th of April. So this is Tuesday, 6th April. But if it is required, I'll probably post it on Monday itself. I'll come to that why I would say that. Okay, so depending on how we go, I'll either post on Monday or Tuesday. So if I post on Monday, it's basically an extra lecture. Okay. All right. So okay. So that is what it is. And then of course the assignment is now extended until 28th evening or something. So please try to submit your assignments by then. Okay. We don't want to extend it further. And these assignments will only get 90% credit. So whatever you score will be multiplied by 0.9, and that will be your final score for assignment 1. Okay. And then another thing is, yeah, I mean, we want you to kind of submit an abstract. Okay, maybe about, let's say, 300 to 400 words, or even lesser is fine. Essentially, we want a half-page abstract with your names and roll numbers. okay, in PDF format on Moodle. So we would like to kind of have this after the break. So okay, so we want you to have this after the break again, probably by if you can submit by, let's say, Wednesday or Thursday after the break, that is either by 7th or 8th of April. If you can submit this half-page abstract on Moodle, I will open up a submission form, and then you can turn in your abstract there, so that we will have some time, and then you can get started with your project after submission, and after you essentially hear back from us. Most likely, unless there is an issue, you should be able to go ahead. If you kind of promise something very too much to do or something, then we will kind of try to steer you in choosing a slightly a project that can be done in 1 month or something. Okay, then you can get started with your project. Okay, after you submit your abstract, and okay, and then now coming to the project, you can essentially you will get pretty much like 1 month time to work on the project. Okay, and you can do it either in pairs. Okay, so you can, two of you can work together, in which case, or you can even, if you want to work on as a only one person, you can work on it as well, as one person can do it if you wish, or you can do it together, that is fine. If you're doing it in together, only one of you have to upload the abstract. Okay, only one of you have to upload the abstract. Okay, then the idea is you work on it for 1 month. Okay, so the project you choose should sufficiently involve work for 1 month, and also after 1 month, probably let's say around the last instruction day or something, which is around May 7th, we will have a final project report, which you will submit, maybe let's say 5 pages in some format. Okay, we will give you the format. It could be either ASME or IEEE format. I'll mention one of them, and then in that format you will write your whatever is your results. Essentially, you will write in as introduction. You can also put in your abstract, results, and then your parallel scaling results, and your description about the algorithm that you have, and then some conclusions. Okay, and then you will also use graphs or any other contours as necessary, for your this thing. So, but you please limit your this thing to 5 pages. I will give you the exact number little later. Okay, but we want you to kind of structure it in this way, something like this, just like any other conference paper or a journal paper. Okay, and then you will of course also upload the code you have developed. Okay, on Moodle. Fine. And coming to the project titles, you are free to choose something that you want to work on that involves, let's say, either MPI or OpenMP or OpenACC, and then the corresponding other than this, you should be, I mean, or it can be a combination of these things, that is also fine, or or if you want to kind of choose something from your, let's say, MS, MTech, or PhD or BTech project, if you want to convert something that you already are working on to parallel, either a part of it or completely, that is also fine. So you can accordingly write the abstract. Okay, so that should be fine. Or if you want to work on something like the automatic OpenMP code generation, like similar to what Professor Rupesh has suggested in the other week, so you could also work on that. So, but then the abstract kind of has to reflect on what would you plan to turn it in. Okay, fine. So that's about the abstracts. Then coming to the lectures, we are pretty much close to finishing the OpenMP stuff. So we have the performance evaluation that is left, which will basically be kind of common for all the paradigms we are learning. Okay, so that is probably one lecture or so, and then plus we have the numerical methods in MPI. Okay, so this I suppose would take another 6 or 7 lectures. I don't know exactly, but because we have already introduced the numerical methods using OpenMP, so it should be straightforward for us to think now, because the algorithms that we need, we have already kind of learned. So probably we have another maybe 6 to probably 7 lectures left in the numerical methods and MPI part. Then we will get started with the OpenACC, and Professor Rupesh will take care of teaching this part. Okay. Yeah, so hopefully after the semester break in 1 week, or a couple of days after 1 week or something, in another 5-7 days, we should be able to finish our numerical methods and MPI part. Okay. So okay, very good. So that's kind of a long lecture. Okay, I'm going to stop here and then open up if you have any questions and discussions. Yeah, I will definitely send a mail on when do you have to submit the abstract. Abstract, if you can submit by 8th of April or 7th of April, that should be fine. I will send an email anyway, because not everybody is here. It's only some 30 students are here. Okay.
So the project should involve parallelization with OpenMP, MPI, and OpenACC, and we can choose any one.
Any one is
method. Only one is fine.
But the only thing is that whatever you are turning in should be equivalent of around approximately 1 month's effort. Okay, with let's say probably 1 hour per day or something like that, or even lesser. But then it should be around a month's effort, because that's what you would be. That's what the time you would be getting. Okay. Any other questions? Okay, I thought we will get so many questions because we opened up the project discussion and things like that.
So could you share last year projects or something similar, so that we could have a reference on what sort of stuff is required?
Sorry, can you repeat it again?
Can you share last old projects or something, so that we can get a reference on what sort of projects will be acceptable?
Actually, we are offering this course for the first time, so we don't have any projects to share. But one thing we can do is, if you want, we can suggest probably some sample project titles. But the issue with this is, if we suggest some sample project titles or something like that, then if all of you want to work on the same project, then we don't want that to happen, because ideally, if you work on different projects, it will be kind of nice, and all of you are working on the same project. If that is okay, probably we will kind of give you project titles or something like that.
Okay.
You can probably get an idea for what is the effort maybe. So it would be nice if you can probably think of a new algorithm or an existing algorithm, and then which kind of poses challenges in terms of parallelization, and then you would try to parallelize that, right? Yeah. Now, one thing is, of course, let's say, everything will carry points. For example, the abstract you submit will carry maybe, let's say, 2 points or something, and the remaining 18 points will be for the project report. And then even in the 18 project for the project report, it will be basically It will be on the report you would submit. Essentially whether you have followed the essentially the format, and then you have given all the required graphs properly, and it's kind of written nicely. All those things that will carry a few points. Then the actual code you turn it in, and the amount of effort that went in parallelizing, which would of course explain your report. So depending on that, and then any challenges you faced and all those things, and then essentially your final results. Okay. Now you may be wondering, like, okay, fine, I have put in a lot of effort and my code is almost ready, but it's not giving correct results. So that is fine. So whatever results you have, you can present, and then there will be points for all other topics, all other things as well. So it's not that you will get a 0 if you don't get results. Whatever the effort you put in, and at least for whatever the report that you write, which will already of course have some kind of a literature or introduction and things like that. So all of them will carry points. So it's kind of combined. The combination of all these things will be your total score for the final project.
Sir, I have a question regarding assignments, sir.
Regarding
the assignments, sir.
Okay, yeah.
So the way you told here that in the project there will be different hierarchical way in which we will grade it. Is this the same with the assignment if I am not getting the proper results? Or
Yeah. That is the same with assignments.
Okay.
Yeah. I mean, we don't want to give we don't want to black and white. We don't want to give 0 to those who didn't get result. And if you that's why if I'm not wrong, in the assignment we asked if to kind of write a line, or a sentence where you say that your code is either it is compiling or running and giving correct result. So you have to indicate all these things such that we will be able to see what you have done, right?
Yeah. Okay.
So I mean, whatever you get, see, for example, let's say it's already Sunday and then you have only getting some result. You can of course turn it in, and then there will be some partial credit for that, for the effort you put in. So it will not be 0. It will certainly be much more than that. So you don't have to worry about that. But then if you get the correct result, it will be really nice. So okay.
Yeah. So I have one more question in this. In
Sure.
the so second question in the last part, the B part, sir, in with
yeah.
the red, black, and diagonal thing. So what is happening, sir? I am using, suppose for test purpose, I am using 0.5. You have said 0.1, but for checking my code, the efficiency of my code, I'm just giving a value of delta s 0.5. So what is happening, sir? That the error, if I'm increasing my number of iterations, the error is still remaining the constant. So can you give me some hints, sir, how where I would be doing something wrong? The error is not changing, sir, or even the values of the results are not changing, even if I'm increasing the number of iterations.
Are you doing it correctly? Sometimes what happens is if you don't have your error computation separately other than the updates, so you have to kind of update all the values, and then you would calculate the errors. If you are not doing it correctly, or maybe you are not updating your phi n+1 and phi n. You are updating this, and then you are forgetting to update the next iteration to be the same, right? You update phi n equals phi n+1 after the end of the iteration. If you don't do that, you probably will be just working with phi n all the time, which will never get updated, right?
Okay.
Maybe that's the reason, or could be to do with the boundary conditions. So in such cases, can you please email TAs? Ravi and Sakti are there.
Okay,
So
okay, sir.
I mean, I kind of instructed them to take a look at the codes and see as much as they can suggest.
Okay, sir. Okay.
Please don't expect them to kind of solve your problem and give back the working code. But what they will tell you is they will probably give you some hints on where there is a mistake or something. There is an error, with which probably you will be able to take on and then fix your problem.
Yes. Okay.
Please contact the TS. They are ready to help. And then just send them an email. I mean, their email IDs are there, or you can post it on the discussion forum also. But then you don't want to share the code on the discussion forum. You can just contact you can send me an email also. I'll forward to TS, or you can just put me in CC, or you can directly email them.
Okay, sir. Okay.
I think they have helped few students before, and then they can definitely help you.
Okay, sir.
Yeah.
Sir, I have a question related to project.
Yeah.
Sir, for the project, I mean, you have allowed it the pairs. I mean, two pairs, people of two
Yeah,
pairs
you
of.
can. Yes, yes.
Yeah. So, will the expectation will be? I mean, will the expectation will be? I mean, according to the size of group, or it will be um, for? I mean, let's say for one student, you have same expectation as that of two student, or will it be according to
Not
the?
really. So not really. If let's say one student has to work on something, expectation is little less compared to the two students per group.
Okay, yeah, thanks. And one more question is like you stated in the assignment that you have to state the entire what I mean you have to state entire the status of your code, like it is working, compiling, and all that. Uh, shall we? I mean, will it be okay if we have included that thing in comment part of the code itself, like where we have written the
Yeah,
code
yeah.
in
That's fine.
support here?
That's fine. See, I mean, essentially that is supposed to guide the whoever is grading to quickly know what is happening actually. If,
Okay.
for example, let's say you got the results and it is working correctly, and your results are correct, then even if you don't write, it's okay because your graphs that you have shown will speak for that. But then let's say if you have included graphs and then you're not getting the correct graph and you get something like this, and then you say, okay, then we can easily make out, okay, this is not correct. But if you don't include any graph, then there is no idea of what's going on there, right? Let's say student A just submits a bunch of code, and then there is no report or something, right? Then instead of we compiling and running and see what's going on with this, if you can say, okay, instead of either TAs or me assuming that the code is not running or something, if you can say, okay, the code compiles, runs, but then it kind of, let's say, diverges, or it runs fine, but the result is incorrect, something like that. If you can say, we will be able to give partial grade accordingly. That's the only thing.
Okay. Okay. And one more question regarding that. Mm, I have one more question regarding that graphs part. I mean, I'm sorry, not graphs part, but the part of generating the output
Yeah.
using which we plot the graphs. So, for the convenience of checking, shall we keep the printing part also in the code, or shall we discard that part? I mean, shall we keep that part, or shall we remove while submitting? Or
That's okay. That's okay. Because we need to say if you have a lot of printer statements and things like that. Is that?
yeah, exactly.
Yeah, it's okay. If you have some debug statements and if you want to leave them there, that's okay.
No. Okay, I think you didn't got the point. What I'm trying to say is, we have plotted the graph, right? But let's say for checking purpose, you might run the result. I mean, run the code again and generate the result or something like that, and check if it is matching.
Yeah.
So for that, should we keep that print statement, or let's say we are writing to the file, let's say fprintf state, something like that. I mean,
Yeah.
so
Please
should
keep all the
that?
same.
Oh, okay.
Yeah. Just please keep all the same.
Okay. Thanks.
You don't have to modify the code for. I mean, you don't have to kind of clean up the code. Whatever the code you have used for plotting, you can leave it like that.
Oh, okay. Yeah.
But many times what I felt is some students take an extra effort to clean up the code because whenever they come back later on, it will be nice and easy for them to follow. Yeah.
Yes. Yeah.
With comments and everything. I mean, some students have, in the past when in the CFD courses and other things, they have really done, turned in very nice programs with all comments and everything. So it's only kind of useful to the programmer because when you come back, later on after 1 year when you actually work on it, then you would not be new to your own code.
Yeah. Okay. Yeah. Thanks.
Sir, I have a doubt. Hello?
Yeah, hello. I think your voice is low.
Yeah. Sir, for one algorithm, requested the
You have to speak up. I can't hear you.
So my code is parallelizing properly, but the computational time taken is greater as I increase the number of threads.
Yeah, that's okay. So that means to say you are not getting the so your parallel time is more than the serial time, is it?
No, for 8 threads, it's taking more time than 4.
Okay. Yeah, I mean, if you can identify the reason why that is happening and fix that is fine. Otherwise, you submit whatever you have.
I already
Are
did
you running on Aqua or something, or are you running on your laptop?
on my laptop, sir. And
Yeah.
this is specifically happening for 8 threads. Could it be
Only
because
for
of
8.
my laptop limitation?
I think it could be because of the that the hyperthreading happening. Essentially, the 4 threads might be finishing and then they are waiting for they are acting as an export or something, maybe like that. Can you would it work with any other number of threads, 6 or something?
No.
No. Okay. That's okay. I think if that is the case, you can mention the same thing. This could be because of the reason, and then you can turn it in. It's okay. But if there is a possibility, you can run on Aqua. You can run it if you have already VPN account in Aqua Access.
Sir, I already submitted the code. I did not mention this. So.
Okay. Fine. That's okay.
Sir, just to add on to the previous question, even I got like execution times which are not in accordance with the number of threads.
Yeah.
So provided the code is proper and like at least some observation regarding why it is not giving the expected result is written, points won't be reduced, right?
I don't think there will be a lot of deduction of points. It should be okay. I will instruct the TS to take a look into that. That should be fine. I think
Okay, sir. Okay.
Yeah. I mean, even if they deduct, just to deduct, they will probably deduct a few points, but it should not be too much.
Fine, sir. Fine.
If you are not happy with, with the few points they deduct, you can just write back, and I'm sure they will give you some more points. We will see that. That's not an issue.
So the project is a maximum of 5 pages, you mentioned, or is that
The project report, right?
Yeah, the report.
Yeah, around 5 pages is what I'm expecting. We can deliberate. If you want more pages, I can increase, but I don't want you to see if I don't put a limit, people will submit some 100 pages, including the code, and they'll just dump in whatever format they want. So
Okay.
We want you to kind of take this opportunity to prepare yourself. Let's say you are submitting for a conference paper, let's say next semester or next year in your research. Then this whatever you're doing for this course, it's kind of a rehearsal for that. So you would put some time and make it in a nice form with everything, and then you can write nicely in whatever you have done in 5 pages, with all the correct plots and what you want to explain and things like that, including, let's say, some reference papers and everything. Maybe I'll increase it to 7-8 pages if it is required. I'll take a look at some of the CFD projects and then come back with that.
Okay.
Yeah, because if we don't put a limit, I'm sure people will turn in, some 60-70 pages as if like a master's project or something like that. So we don't want that to happen.
Yeah, got it.
And then actually, in fact, it is difficult to write a 5-page report than writing a probably a 100-page report, because you have to think and condense and say what is the important things that you want to say. If it is 100 pages, you can just dump one figure in every page and it will go on. Yeah. Other questions? Do you have any ideas? Can you share if you have any ideas on what project you want to work on or something? Probably one or two of you. Let's say if you have some research code you're working with, you want to parallelize, or some other idea that you came across, or from the lectures or from anything like that.
Sir, I have just an idea on. I was working on Icing model.
Which one? Call?
Icing model.
Okay.
So it is basically. Hello.
Yeah. Please go ahead. Yeah.
Yeah, so it is basically we're trying to solve the Ising model using
Icing
the
model, is it?
yes.
Icing model. So basically, on let's say icing happening on an aircraft windshield or something, is it?
No, sir, ISING. That
Which
is
one?
ISING. It is the principle of statistical mechanics where
Oh, okay. I'm not aware of
we
this.
try to
Okay.
minimize. Yeah. We try
Can
to
you please?
minimize Hamilton this energy function.
Okay.
So, but the code is written code is on in CUDA.
Okay.
I just want to, but the number of lattice I could create is small.
Okay.
I want to just bring, compute for larger lattice point. I think
Okay.
I should use MPI, but I don't know how to integrate CUDA with MPI.
Okay. Okay. I don't know. Maybe Professor Rupesh, maybe he can say something if he can do something like this.
Yeah. So this is definitely possible. You can also run this on Aqua. So you can combine MPI and CUDA. That's not an issue. So you'll be able to. I think this is good. I mean, you already have code in CUDA, and you want to now extend it, scale it to larger set of input data points. So that should be okay. And just make sure that there is enough work to be done when you are trying to scale this up. So that should be all right.
Yes. So just the issue is that how much part should run on as in the single node, and then how much should be communicated. Is there any rule of thumb?
We will discuss few things. Basically, your question comes back to something known as essentially speed up and efficiency. We will come to that in some time. Essentially, you don't want to spend a lot of time in communications because communications are expensive, right?
Yes.
Yeah. I don't know if that kind of answers your question. Maybe I will leave it to Mr. Rupesh to answer if he has to say something.
No, I mean, yeah. So whatever we are studying in MPI part, I think all those concepts are mostly going to be applicable. So, I mean, you would like to reduce communication as much as possible, but then you also want to improve the parallelism. So, I think it's definitely going to be something which you have to think from the Icing model perspective.
Okay.
Yeah, Kameshwar, I want to make one point.
Sure.
Yeah. Although we have mentioned that you can, let's say you are doing some serial code as part of one of your projects, let's say, and you want to parallelize it as part of the course project for this parallel scientific computing.
Right.
It may not be a bad idea to keep your advisor informed that you are trying to do this.
Yeah.
Just as a cautionary note to students.
Yeah. So that is I think a very good point, Professor Rupesh. So yeah, please keep your advisor informed that you're working with the code and that code is what you are trying to parallelize for the purpose of this course, because we essentially ask you to submit the code and we don't want your let's say research advisor to feel that okay, you have given away the code to this group and to this program or something, because it's something that is your in-house code and you don't want to kind of give it away. So please keep your advisor informed so that he would also be either happy and when if you work on that, or if he says no, don't work on this one, then kind of work on something else, at least that is similar to what you are working on or something like that. Okay, I think that's a very good point. Yeah. If you're choosing something that is not given to you by somebody, then I think you're free to then you don't have to kind of inform anybody. But if you're taking some code that is used in your group and you're trying to parallelize it and submit, probably it's a good idea to just kind of drop a line to your advisor informing the same thing. Excuse me. Any other questions?
Sir, we have any standard libraries to use OpenMP or MPI?
Standard library
Graph.
for linear algebra or for what?
Graphs
For
related.
graphs. For linear algebra, I think there is something called LA-Pack. I think that has certainly MPI based things. I'm not sure about OpenMP. For graphs, for general graphs, is it?
Yes, sir.
For general graph partitioning, yeah, I think there are algorithms. There is a library called Metis and Metis. If I'm not wrong, these can be used for general graph partitioning. This is pretty much actually used in CFD. When you basically get a unstructured mesh, you essentially end up with a kind of a graph. So that meshes, uses the Metis and Metis to kind of partition as well as perform, load balancing and things like that. I don't know if that is the thing or if there are more. I'm not very much aware, but there must be many. Also, have you guys come across any tool like we discussed in the last quick Q&A, which will convert? Let's say you give a program and you will get either MPI, OpenMP, or CUDA, or OpenSCC, something like that. Have you come across any projects that are working in that direction? There's a question here in the chat box. No? Okay. Any other questions? Anybody from the lectures or, How is MPI in terms of learning compared to OpenMP? Is it easy, difficult, different? Any comments? Or it's getting confused because of OpenMP before? Okay, I think you're already on vacation mode. I think everybody is so quiet today.
I think it's a bit different from OpenMP. I found OpenMP kind of easier. I think
easy.
Maybe the enthusiasm was much more at that time. Maybe, but it was quite better there. But it is fine.
It's fine,
yeah.
Yeah. So MPA seems to be little. I don't know if this could be my observation. I think does it feel like it has lesser pitfalls when you try to parallelize using MPA than OpenMP? Because you essentially have only local variables everywhere and then few global variables and things like that. Does it? Do you have a similar observation or?
I feel like, sir, MPI has a lot of detailing, sir, in comparison to OpenMP.
Okay.
A lot of detailing and like we can do a lot of things.
Right.
Yeah, that's.
Yeah. And also it kind of depends on how you design your algorithm, right? How you partition. And
yeah. There are its possibilities are more deep.
Yeah. So yeah, because you guys are not asking questions, I will go and teach a lecture now. So this is regarding projects. Let's say we have already learned Gauss-Seidel successive over relaxation, right? So we said you use some alpha, and if this alpha is greater than 1, you call it as over relaxation, and this over relaxation is what makes the code kind of converge faster, right? Now, this was, of course, Gauss Seidel was very old, but recently in the past 5 years, there was some revived interest in Gauss Seidel. Okay, so you will see a bunch of papers getting published in the last 4 to 5 years, and then the thing is, this alpha is kind of is not known, so you have to kind of only guess alpha by trial and error. So if you take, let's say, alpha to be some 1.05 or 1.1, you will basically get some kind of convergence rate from here. When you try to solve your linear system. Now, but this is not known how much to take this value. And then usually, if you write a Gauss Seidel successive or relaxation, you would keep alpha to be some value, and then that will be kept constant for the entire number of iterations. Now, in the revived interest, what people have looked up at is, can you change alpha, okay, based on the number of iterations? Basically, as you are going with your iterations, can I keep changing alpha in a not kind of randomly, but using some algorithm? Can I drive this value such that if I take too large a value, the code will diverge, but if I take too small, there is no advantage. So can I change this alpha such that it will kind of converge, the Gauss will converge in, let's say, in a minimum number of iterations? Okay, so of course, this is not an easy problem, because while solving an iterative method, you are essentially now posing an optimization problem. Okay, but people have done some effort in this thing, and that is known as Gauss Seidel. It's called schedule relaxation Jacobi. Okay, or just a schedule relaxation Jacobi or schedule relaxation Gauss Seidel, in which you will kind of SRJ. Okay, but the problem is, this has to be done in such a way that the effort of doing all this optimization should not be overwhelming compared to just solving the system. Because if that is the case, we would not take the pain of calculating optimization and all, because if it is too complicated or too expensive than the original problem. Okay, so people have done something like this. So this could be a something that we can work on. But of course, you have to first learn what is schedule relaxation Jacobi, and then the algorithm, and then see if there is scope for parallelization. So that is something that we can think of, maybe, if you want to do. Just an idea on the parallelization things. Or you could probably work on something that is known as multigrid, which I have mentioned before. Okay. Or any other method that you kind of work on. Any other questions? We will see if we can kind of populate maybe some sample project titles, so that we can probably look up them and decide on a particular title. Okay. Now I was expecting probably somebody would ask, if I put in effort, will I be able to extend the course project to get a conference paper or a journal paper, something like that? I was expecting this question, but none of you has asked about it. Does anybody still want to ask such a question?
So I suppose to do that, we need to do a lot of literature survey on the domain of parallel processing in our respective domains.
Yeah.
So I think that would be like an additional thing to read up in addition to the project itself,
Right.
to extend it to a paper. So I guess if that can be done, then it can surely be extended to a conference or journal.
Yeah. So it's not just about the literature, also it's about the amount of work you have to put in. It may not be possible with just the 1 month that you would put in, but then let's say if you put in effort afterwards into the summer and things like that, maybe something more meaningful can be produced from the effort you put in. That is definitely possible, but I think it kind of depends on the effort and things you would put in after the course as such. Yeah. Anyway,
so whatever we do as a paper to like formulate a certain aim for the paper should essentially be better than what has already been done, or should not be what has already been done. So I think that can only come from a thorough literature survey, which we should take maybe about a month for. Or if you're working in pairs and some of us have already done that type of a survey, then I think it should be more feasible.
Correct. Yeah.
Sir, also one more point, like let's say if we want to convert our project into a paper or something, then I mean it will be slightly difficult if we start with our own code. I mean, own code written from scratch. I mean, it will be good if we have some baselines for that.
If you have what? Some baseline.
Baselines.
Yeah, I mean, it cannot depend. Depending on the problem, you could probably have to write from the scratch. Sometimes may not be. So, yeah.
Yeah, so what my point was, it might get good publication if it has a baseline. I mean, we have a baseline for already implemented. I mean, someone has already implemented, and if we try to improve over it or something like that.
Yeah, what you're saying is correct. I mean, what I meant was basically you worked on something for your project, and then let's say you kind of refine it, as someone else suggested. You would refine it by looking at the literature review, and then you would change your program and make it better. And you put in this effort of let's say the literature review and things, and the improving the program will come later. Essentially, you do basically something for your project, and then later on probably you can think of if you can extend it to a something for a conference, something like that. But I may not agree very well with the idea that you should have a code to start with, because, for example, let's say you want to start off with a new problem that is in your mind, then you probably would have no baseline, or something. Then you can, of course, start writing based on that. I think it all depends on the kind of problem we want to attack.
Yeah, sir. But for let's say you are saying for most of the problem, let's say you are working on CFD or something like that. Most of the work would be, there will be some work already been done in all the fields, right? Let's say if you pick up in CFD, then let's say there are 5 algorithms, and there would be already something done on that things.
Sure.
And it will be how we can improve over that will be the question, right?
I mean, it need not be completely an improvement. It can be an evaluation of, let's say, a few methods. For example, let's say, I don't know if people have done it, something like this. Let's say you want to improve upon red black or something like that, and then you can evaluate different methods and things like that. It all depends on what is done in that area. But yeah, I mean, if you talk about a particular area such as CFD, then if you start off with something, it probably won't lead to a publication as such. But let's say you want to analyze the data that is, in terms of, let's say, COVID spread or something, and then see if we can parallelize some of those things in terms of analyzing and things like that. Then that has nothing to do with, essentially, it's more of a applied mathematics or mathematical problem, right? So you would think of analyzing some of the data in parallel and then coming up with some patterns and things like that, and say this is how it is happening. So such things don't need a baseline. You would probably start with something from scratch.
Okay, got that. Yeah. Thanks.
Any other questions, anybody? Okay, if there are no other questions, what I will do is let's call it a day then. It's 5:55, and then we will meet up in 1 week's time. Okay, in April. Fine. All right. Then thanks everyone. Have a good weekend and a good semester break. When we will return, we will have we'll resume our course again. Okay. Thank you. And please submit your projects if you have not done so by the deadline. All right. Okay. Thanks, everyone. Bye.
Bye, everyone.